Hello, everyone. Welcome to the demo of artificial intelligence and generative AI. Let us start the session. I think few people will still be joining, but no problem. This is recorded session and you'll get the recording. Let me quickly share my screen. This is a demo session. I will try to take one example of the end-to-end life cycle of AI and then we'll understand like what are the core components of this AI. So this is the first session which I generally do, where I try to explain them different components of AI and where does each and every one of us fit in this entire equation, right? So that's the point of our discussion today. If you have already gone through the session, kind of, sit back, relax, and listen to it if you have gone through this demo previously. But if not, this would be pretty much new to you. So the session is called as end-to-end, you can say end-to-end AI life cycle. So in this one, we try to understand what is the end-to-end AI life cycle looks like and where is the world trending and all that stuff. So we'll take a step back. We'll go say like a 20-year back. Okay. So 20-year back, I'm taking an example of a bank. And imagine I call this as an ABC bank. ABC Bank, if you see 20 years back, 25 years back, somewhere around 2000, 2005 era, right? So that era, if you see, typical banks, used to operate. You might have a teller. And basically teller does, withdrawal of the money, deposit of the money and all that stuff. And typical transactions goes and sit into something called as operational data stores or the RDBMS systems. ODS, they're called as operational data stores, or typically you can also call them as RDBMS systems, like relational database management systems. Now, what does all these transactions look like? They are like somebody's withdrawing money, somebody's depositing money, somebody's opening up a fixed deposit or applying for a loan. All that transactions goes and sit into this RDBMS. And imagine the bank has employed an analyst to analyze these patterns. They wanted to understand how many deposits happened on that day. How much is the monthly average balance of the bank? How many applications are coming for loan for that month? Imagine these are the questions. And if we have to analyze those transactions, the analyst used to write SQL queries on the RDBMS databases or the operational data stores. And these SQL queries used to run during the time where the regular business operations are happening. Right? So the teller is doing a withdrawal or deposit. At the same time, we are also running the SQL queries, which actually slows down the operational system. The operational actual tables slows down, and that creates some problem. Basically, it creates like a issue like slowdown of the system and so on. If you think the regular business hours are like 9 to 5, then a new concept came into picture that let us not run the SQL queries during the day, but you run during the night. And then you run something called as nightly jobs. So you run nightly jobs, which are run during the night. And these jobs basically run these SQL queries on the same databases. So imagine the business hours are 9 to 5. These jobs were run during in night, say like 9 p.m. in the night, 12 p.m. in the night, or 1 a.m. early morning, 3 o'clock a.m. and so on. And what these jobs used to do, they used to create reports for the senior management so that they can take decisions on the next day. And this used to work for a very quite a long time, very successful model. Till the time there are two things happened. First one is adoption of internet, and second one is geographical expansion. So adoption of internet and geographical expansion, what they did is they have reduced this business time, right? So there was no such period, or we typically call it as a lean period. There is no such lean period in which I can go and run the nightly jobs. Imagine, because now internet was adopted, people were creating websites, people were creating mobile applications, and the banks got the websites and mobile applications, and people were transacting with the bank throughout the day. So it was we can't say that in the night the bank operations do not happen because my bank is shut. It's not like that, because internet is available, people were still able to do those transactions. At the same time, geographical expansion happened. Companies set up their companies in different parts of the world. It's not like it is only in US. So companies, as the US company, have opened in Dubai, UK, Australia, and different parts of the world. So when US is awake, Australia is sleeping. When US is sleeping, Australia is awake. So that throughout 24/7, there were transactions happening. Well, because of which we had problems. Problem is that I can't run my nightly job during the night, because night is day for some other geography, or there are people using internet for accessing during the night. That's when the data warehousing systems came into picture. You might be very familiar with this term, data warehouses. They're called as DWH, data warehousing systems. So data warehousing systems, what they do is they do the movement of the data from the ODS, operational data stores, to the warehousing stores. The process is called as ETL, extract, transform, and load. Extract, transform, and load loads the data from the warehousing system, from the operational systems to the warehousing systems, so that they decouple the actual tables with the warehouse tables. Now, I can run these nightly jobs on the warehouse tables rather than running on the actual tables. That's the great advantage. One other advantage which data warehousing table brings onto the table is that they store historical data. So historical data is like last year data, 5 years back data, and so on. If you store historical data, we can create reports by doing comparison. Like, what is the sales of the product last year when compared to this month, right? How much is the monthly average balance of this week when compared to last 5 weeks? So if I want to do such kind of reporting, I'll be able to do it, and you get a lot of advantage with that. So that is about the data warehousing systems. Now, data warehousing systems have one disadvantage, is that they are only storing structured information. They are not capable of storing unstructured information, right? So as the years progress, like 2012, 2015, and so on, the world has moved towards unstructured data storage. So they, instead of data warehouses, of course, data warehouses are also common part of it, but one other system emerged, which are called as data lakes. Now, what these data lakes does is, like, imagine they are the large volume storage systems, and they will be using for storing large volume data processing and so on. Primarily, they were built on Hadoop. And eventually, as the cloud progressed, like we have cloud storages like AWS, Azure, GCP, and so on. Data lakes were created in most of these cloud providers. And what these data lakes are capable are, apart from your regular structured data, It is also capable of storing unstructured data in terms of, suppose, say, video files. You can store videos. You can store audio files or music files, or you can store audio files. Then you can store text data. You can store log data. You can store any information from, say, like IoT devices, like sensor data, and so on. The world has moved, and what we are now doing is we are storing unstructured data in terms of images, videos, text data, chat information, logs information, system logs, performance logs, and information from semi-structured information from sensors and IoT devices and all that stuff. So this entire piece of equation where we are trying to do data storages, not only from structured information, but we are also storing unstructured information, may it be the mainframe flat files, or it can be from your unstructured or semi-structured MongoDB store, JSON information, or anything like that. All that information is now pushed into data lakes. This part of the equation is called as data engineering. Data engineering, this entire equation section, or I would say section, is basically called as data engineering, where people will do a lot of data engineering processes. Once the data is stored, then we do something called as exploratory data analysis. Exploratory data analysis. Right, so this exploratory data analysis, or we also call it as EDA, is like creating graphs and charts and so on. So you want to create some kind of meaningful graphs and charts on what the data is trying to talk. That is what is called as exploratory data analysis. This is like a first cut analysis of your data. The raw data is analyzed to understand patterns and what are the different dimensions of the data, and what is the data trying to tell, what is the data trying to speak. So that analysis is done. People will use traditional tools like Tableau, Power BI, or we can write our own Python specific program for creating those graphs and charts and so on. After we do analysis, we create something called as features. It's part of something called as feature engineering. Feature engineering or creation of feature stores or feature marts. In the feature engineering, what we do is we will have this raw data in data lakes, but now we do some kind of joins between multiple tables. You try to create some kind of aggregations. You try to remove unwanted columns, create new columns, create new aggregated data and all. All those things are called as features. And these are reusable components, and these are reusable across the different experiments which data scientists conduct. And that information is stored into something called as feature stores or feature mart. Once the features are created, the central piece comes is where we do something called as modeling. Now, modeling is the piece where we do something like supervised machine learning. We do something called as unsupervised machine learning. We do generative AI. and all other modeling techniques. So this modeling is where we will try to do a lot of these processing of supervised, unsupervised, and generative AI based techniques. And these generative AI based techniques helps us to create new content, create new applications. And nowadays, we are also creating something called as agentic AI-based systems. Now, what this will do is it will use all the data from raw data, feature data, analysis from your exploratory data analysis, and creates future predictive models in supervised machine learning. So I'm just giving you an example that what these different tools are. But within supervised machine learning, we have almost like hundreds of models. In unsupervised machine learning, we have so many models. In fact, the generative AI, we have a lot of LLMs available for doing a lot of LLM-based analysis. So this is a central piece. Now, central piece basically creates models, it creates outcomes, it creates predictive applications, and so on. And many times, unfortunately, people only talk about this central piece. They only talk about saying like, okay, what is generative AI? Or they'll talk about different machine learning algorithms, and then they talk about accuracy, prediction, and so on and so forth. Even in academics, and that's where the entire course or the coursework or the subject stops. But the reality is that this modeling piece is one small piece of the entire equation. This, you can think like this is a one Lego block of your entire building. The extension to this is like, how do you deploy these models into production? Now, that is ML ops. So we will generally discuss about something called as deployment. Deployment is again divided into two sections. One is called as a batch deployment, and second one is called as an online deployment. A batch deployment, you can think like a batch job which is running every day, say like 9 p.m. And this can be run on some cloud provider. So you have an AWS cloud, and then you have the model running on the AWS cloud. This is your loan model. And then you invoke the batch process. And the batch process basically does like, it runs on a scheduled manner. Every day, 9 o'clock, we run this batch job. And the batch job takes all the applicant information for that day, and then does the prediction whether the person should get a loan or not, right? So imagine there are 100 applicants during the day. It will predict that 82 applicants are eligible for loan. The rest of applicants are rejected. So you can think like this is like a scheduled job, which does the prediction in a scheduled manner. So that deployment is called as a batch-based deployment. And this process is typically called as ML ops or LLM ops. So if you're deploying machine learning models, it is called as ML ops. If it is deploying generative AI models, you call it as LLM ops. Like, how do you take this model to production, right? So batch way is one specific way. Online way, you can think like this is a real-time model. So online one, you can think like you create a real-time API. And this API is invoked by maybe a website or a mobile application, right? So imagine you log into the abcbank.com, and within the bank, you have some form. You fill the form and you give all the details, and then you have a button. You click the button, submit button, and the form routes to the next page, which does a direct calling of my API. And that API basically invokes my model in the real-time mode, and that gives you prediction. So you fill a form and then say submit, apply for loan or something like that. In the real time, your model gets invoked, and it will give you an instantaneous response. So that kind of deployment, we call it as online deployment, or we can also call it as a REST deployment, REST-based REST-based deployment. One other important thing which we generally learn is called as monitoring, which is also an extension to the MLOps. It's called as monitoring. Monitoring has two important components. One is called as explainability. And second one is fairness. Okay, pardon with my writing if you are not understanding. Hope you will certainly understand as the course progress. But monitoring is again a very crucial piece. What monitoring says is, okay, you deployed the model into production, but after the model is deployed, how is it performing, right? What is the current state of performance of the model? Imagine you have deployed the model in, say, like January 2025, you deploy the model. And in May, now you want to understand the model which you deployed in January, is it performing good or not? Right? So what is the current state of the model is something very, very important. That is called as monitoring. Monitoring has two important pieces, explainability and fairness. Explainability talks about if we are doing some prediction, on what basis did we do the prediction, right? What are the what are the reasoning? What is the reasoning behind doing certain kind of predictions? So we have certain kind of metrics to gauge the explainability of the model, say like whether it is doing predictions correctly or not, and on what basis did it do the prediction. So that is the explainability angle of it. A fairness angle of it is the model should not have any bias with respect to demographics, gender, caste, creed, and any kind of discrepancies. It should not have any bias with respect to any of those variables. And it has to have a fair prediction, whether it is for a male or a female, or for a specific type of gender, or maybe caste, or nationality, or anything like that. So it should have fair modeling. That is that is the fairness angle of it. Again, we have some kind of metrics which basically analyze the fairness angle of it. And one more last piece we generally cover is the we call it as AI protocol. AI protocol, in which we have two important angles called as governance, and the next one is quality. So if you say governance and quality, what we are trying to determine is we are trying to determine whether your model is having proper governance or not, right? So what does the model build on? Does it have all the explainable parameters? Does it have all fairness parameters? What all metrics are being guided? How much revenue the model is making? Is it making in a real proper sense or not? All those things come under the model governance place. Quality is where you're trying to determine the quality of the model. Like this is the quality assurance. It will ensure like how model is performing. Is it performing according to the business requirements, the functional, non-functional requirements, and all that stuff will be gauged in the quality assurance section, right? So what we have learned in the past 30 minutes, we quickly wrapped up a lot of things in the 30 minutes. What we saw is like we went back 20 years back, and then we saw how jobs used to run. Then we saw the importance of data lakes. Then we are coming into the modeling section, and then progressing into the operation section. So this central section is where we have jobs like data scientist, and so on. So these are the core jobs which are having some programming background. So this piece, central piece, is where we have data scientist kind of roles. This section is where you are having ML engineer kind of roles. ML engineers are the ones who are responsible. These are having the knowledge of DevOps and other things. These are the ones who are responsible for doing productionization of the models and doing the deployment of the models and so on. So all those important things are covered in the ML engineer perspective. Then we also have here ML tester. These are the ones who are responsible for quality assurance and other kind of roles. So this is like the entry point for somebody who is from a QA background and want to get into the AI. So this is a good entry point, and after that they can go get into the ML engineer role or a data scientist role. So from here they can either graduate into a data scientist role or maybe an ML engineer role, and then go forward. Somebody who is having DevOps background, a good entry point will be ML engineer. And eventually from ML engineer, they can get into data scientist. Somebody who is like from application developer, front-end developer. So for them, data scientist path would be a good entry point. Junior data scientist, senior data scientist, and so on. Right? I want to take a few minutes. If you have any questions, we'll discuss, or else I'll brief you some of the other course related information, like what we are going to cover in the course. Any questions, guys?
No, Sitaram, thank you.
You can use the chat window. If you have any questions, what I would recommend is put that in the chat window as and when you get, right? So while I'm looking at the course, I'll also look at your chats. So I'll answer them as and when you're getting questions. If you want to speak up, then I'll schedule some time. We will generally have a 10-minute, 5 to 10 minute at the end of the session so that we can discuss at that time. Any
So
questions? Yeah.
this is Sudhakar regarding this batch, and you have given different, right, online and batch.
Yes.
So API means how it will be like the old process, like you are using uh, uh, like what I can say, streaming process here using the Kafka.
Yeah, so APIs, you can use any of the frameworks for creating APIs. In data science, ML, AI world, we use Python as a native language, and
Mm-hmm.
Python have two very good frameworks called as Django and Flask. So we'll use either Django or Flask to create those APIs. Kafka streaming and all those things will also link with that. For example, in real-time mode, the Kafka stream comes and then we feed the stream to direct API, and that API call happens. So API call happens, and then the response can be again pushed to Kafka stream. So that kind of setup can be done.
Okay, the monitoring and everything will be part of this in year itself, or do we have any intermediate tools to be that will be taking care? We just pointing to the endpoint. We are just capturing like posting and getting, right? There is
Yeah.
another word also that we call
Yeah. So that
publish and publisher and all, right?
correct. So there are two things.
Mm-hmm.
One is the monitoring tools come up some of the monitoring tools are bundled with the AI systems, right? So they are
Mm-hmm.
part and parcel. Some of the open source tools are there, some of the closed source tools are there. They are part and parcel. The monitoring systems are part and parcel of the AI systems itself. Some of them create external systems, like I can push it to a Prometheus or Elk stack. And from there, I can create my own Grafana dashboards to show the monitoring and all the stuff. So that is like, if you want more customization and so on, then people go to that kind of a route. So we publish our logs to those servers. And from there, you can create reports and so on.
Okay. Okay. So means in both options we have it. We can have AML also have their own
Yes,
monitoring process, or you can integrate with other monitoring tools also.
correct. Depending on the
Oh,
requirement, people do that. Yes.
okay. Thank you.
Any other questions? Anything on this, what we are discussing? I hope you guys are following, right? So,
Yeah, we are following. Thank you for that. So this current what the course is going to be started from data science layer 3 onwards, right? Explorer, data analysis and modeling, feature engineering. This is the one will start it
yes, yes. So
from
that
this
is the
one, correct?
central piece. Yeah, from the exploratory data, modeling, feature engineering, deployment, monitoring, AI protocol, and all that stuff. We will that will be our course.
The part what is there in the left side that is existing our source of the data for us basically. Is there any of this one?
Correct. Correct.
Oh,
Sitaram, what is the
is
difference between data engineering and data scientist?
Data engineering is where you have to connect your input data sources to uh, the place where we do the connection, or we say ingestion from input data sources to storing it as a data lake. That piece, right? And it also involves a little bit of feature engineering as well. For example, you want to transform the data, all that stuff. So that we will use data engineering. Data engineering is where we do that. Imagine you have some mainframe system and you want to read files from the mainframe system and then push into the cloud data lakes. That ingestion pipelines will be created by data engineers. And then you have 5, 6 tables and you want to transform all the tables and then create one single table for your underlying machine learning usage. So then you do all the transformations required. That will be created by data engineer.
Just like ADF or Informatica's, those type of ETL tools.
Exactly, exactly. So ETL is like data warehousing terminology, but data engineering goes a little beyond. It's not only structured, it can be unstructured also.
Oh, okay. Basically, when we are extracting the data from other source systems and storing into a data lake, and from there doing some transformations, then it comes into the bucket of data engineering.
Yes. Job roles are data engineers. You will see data engineer is the job role.
Okay. What about data scientist?
Data scientist is the one who is creating these models, supervised machine learning models, unsupervised machine learning models, generative AI models. All those things will be done by data scientist.
But while creating these models, that will be on top of that transformed data which has been extracted from different sources.
Correct.
Okay, okay, thank you.
So depending upon the type of the company, if it is a small company, these roles overlap. Data engineer, data scientist, everybody. So there will be one full stack data scientist, and that person will be doing data engineering work. That person will be creating pipelines. That person will be creating models. That person will be deploying the models into production, and so on. If the jobs if we have what I mean to say, bigger companies, these roles are clearly defined. Bigger companies, MNCs and Fortune 500 kind of companies, right? So the roles are clearly defined, that what a data engineer does, what a data scientist does, what an ML engineer does, and so on. And in fact, we have visualization engineer also who will be responsible for doing dashboards and pipelines, exploratory analysis, and so on. But when it comes to, say, small companies or startups, right? So these roles overlap quite a lot.
Okay. It seems to be data scientist and the ML engineer both are same, or any differences are there?
Hmm. It's a good segue to what I want to talk next. So there is a big confusion between AI, ML, data science, and all that stuff. So let us kind of. So AI is a big umbrella term. This is a concept. Okay. And people are saying, I work in AI. AI is a concept. AI, what it does is we try to create we try to create machines to do the work of humans. We try to automate. That is the purpose of AI. Artificial intelligence is where we're trying to make machines do the work of humans, so that humans, the manual, boring, automated tasks can be automated. Repetitive tasks can be automated and can be done by machines. That's the first thing. Machine learning is a subset of AI. Now, for this automating the task, imagine I have large volumes of data. I am not able to find out patterns. I need to use some statistical techniques to automate these tasks, to create some kind of predictive methods and so on. Some statistical outcomes can be created, and that is ML. ML is a subset of AI. It is where you will be using different machine learning techniques, which will be used for doing predictions. So there is a question that RPA is a part of AI. Yes, RPA is one. RPA is more of a rule-based engine, right? If you think, RPA is a rule-based engine where you say, if A is done, then you go to B, and if B is done, then you do C. It's a more process-oriented. When initial years, when AI was invented around in 1950s, the first kind of set of automations were done are now called as RPA, or robotic process automation, right? So you could think like RPA is more of a generalized AI. It's a what I mean to say, conditional rule-based AI. But I can't create the rules. I have to use some statistical models. That's when the ML comes into picture, right? You can use machine learning algorithms. You create the algorithms, and those algorithms will create the rules saying that if this happens, then you have to do this. But the rules are very known to the algorithm, but not to us. It will not be very clear for us. The model does it. Within the ML, we have another one called as deep learning, which is where we are dealing with images, videos, text data, and so on. So it's more of dealing with unstructured data like images, videos, text data, and so on. Within deep learning, we have something called as generative AI. Generative AI, or Gen AI, what it does is it deals with images or videos or text, but it is generative in nature, which means that it creates the data from the already existing data. Deep learning can be used for doing predictions. For example, I show an image. For example, our iPhone's face detection, right? It's a deep learning model. It looks our face and then determines it's me, and then it unlocks. So the face ID, face scanner, that is an application of deep learning. Generative AI is the application like our chat GPT kind of a thing. So uh, I can request question, it will generate the answer in a much more meaningful output. Within generative AI, now there is another thing coming up called as agentic AI. agentic AI, which goes one step further, where we try to do API calls. So generative AI LLM will be used where you will be creating some kind of text. And then from there, you can also do some external API calls like, creating a flight booking or automating a email message, sending emails, calling a database, doing a user verification. All those things are basically some kind of agents you can create, and those agents can be orchestrated by my generative AI application. Now, this is all the information about AI, ML, deep learning, generative AI, agentic AI. The one which cuts across these all tooling is data science. So data science is where you will be using different statistical techniques. So in this, you use a different statistical techniques. It is the one which is connecting all the pieces, like how do you do exploration? How do you do visualization? How do you create functional applications? And how do you do operations, for example, machine learning operations and so on? All those things come part of the data science. And there is also an overlap between data science and data engineering. I can create data engineering here. In data engineering, we also have another smaller thing called as big data. Big data is quite big, but I'm just drawing a smaller circle, which is talking about large volume data storages, data processing, and so on. So with this graph, I think now people might have got a little understanding. Irony is people say that AI is different, ML is different, deep learning is different, generative AI is different, everything is different, but they are all linked together. And a big irony is that many of engineering colleges, now I'm in India, I'm in Hyderabad. If you see many of the engineering colleges, they have CSC in AI, CSC in ML, CSC in generative AI. Now they're creating new course called as CSC in generative AI. So it's like real crazy that all of those courses, all those computer science engineering courses teach the same subjects, just that the name is different. And one of my cousins also recently inquiring like, should we go to CSE AI or CSE data science? Data science is old thing and all. So I said that all this is just to mint money. Just enroll your kid into basic CSE. And he saved a couple of lakhs just like that. Okay.
So
So
Sitaram, here deep learning is a subset of machine learning, no?
yes, it's a subset of machine learning.
Same like generative AI is subset of deep learning.
Yes. Deep learning is a subset of machine learning. Machine learning works with more structured data. Deep learning is a subset of it, which specifically works with unstructured data.
There's something called neural networks and
It,
natural
yeah,
language processing that will be other part of machine learning.
that is deep learning. Neural networks is what is part of deep learning.
Oh, that means within the deep behind the generative AI, neural networks will come.
Yes. So deep learning is pure neural networks. Generative AI use one type of neural network called as transformers. When we say chat GPT is called as generative pre-trained transformer. It's one of the neural network architecture. GPT means generative pre-trained transformer. Transformer is one type of neural network. Architecture.
Okay.
All right. Any further questions?
One question.
Yes.
So how deep we are going in this course? We are going to the genetic AI, or which level we are going in this?
We're going till agentic AI. We're going far deep. So it's a 2 month
Okay.
course. I was just
Mm-hmm.
trying to give that. So it's a nice segue. I guess your questions are into exactly going into the way I want to drive the session. So this is a 2 month course where we'll be initially talking about the basics of AI ML, and then we will learn the Python, which is very, very important language. All these things we will be learning using Python. So we'll do Python language, so Python for AI, and then we'll then get into machine learning. Very, very core concept. So we will spend a good 20 to 30 days on machine learning itself, and then we'll get into deep learning. Then we'll get into generative AI, and then to agentic AI.
Hmm.
Okay.
So,
Thank you.
so is it mandatory to have knowledge on Python before attending this session?
If you have any other programming language knowledge, it's good enough. But we will spend a couple of weeks on Python itself, where we will learn about different ways to use Python libraries for writing programs. So during that time, you should be familiar enough. Even if you don't know Python, you will get familiarized during those weeks. So it's like a refresher will be there.
Okay.
Hi, sir. This is Venkatesh.
Yes.
Sir, I am basically from non-IT background. Actually, I want to move to IT. Is it correct way to learn this course?
Uh, It depends. I generally, what I do is I try to understand more details about yourself, what you have done so far and all, and then can give you a required guidance. So if you have questions, probably reach out to the organizers. We will connect offline. It depends on, how you wanted to project yourself, right? So based on that, this requires proper planning, and then it will help you to get into it. Ideally, I have seen examples on my previous course students where they have from a non-IT background. In fact, they were from finance background, not IT itself. They were like completely diagonal background. So they have done BCom and finance kind of a thing, but now they've come into data science. So it is possible, but what we need to do is we need to analyze the current what you're currently doing, how you're doing, and then take it forward. Please talk to the organizers, and then we'll connect if
Yeah, I
required.
will connect with Career IT. Thank you, sir.
Thank you very much. All right, then. So we'll continue this few more sessions. We will have few demos to understand. So you'll understand the way I am teaching, and then you'll certainly understand more details about myself also. Cover few more days, and then if you guys are interested, reach out to the organizers. They will confirm your seat, berth, and booking, and then we'll start our journey.
Yeah, one last question, Sitaram.
Yeah. Go ahead.
So this training like take into some kind of a certification, or any certifications suggested here after the course, or
There are certifications specifically from cloud providers, AWS, GCP, Azure. What I would generally recommend is after this course, you can go and you can write those certifications. There are basic, and for advanced levels, you need to know more of the cloud-based understanding. But there are basic certifications. You will be able to crack them after you complete the course. But what I generally suggest is we need to focus more on projects, rather than certification. So I would I would try to give more preference to people doing projects on GitHub. We will be doing throughout the course, we'll be doing minimum of 10 projects. And so
I know, I agree that point. You are giving live demos. So what my intention is that the certifications, like you are considering as a generic, you are talking about generic of this all the fundamentals of fundamentals in the deep running of the common way you are explaining, or you are specific to entitled to some of the certification.
No, it is not gearing towards any specific certification. This is generic way.
Okay.
It's
Okay.
not like a certificate course, like AWS certified generative AI assistant or associate. So it's not like that. It is a generic course.
So most of the time you are using like which cloud you are using.
Most of the course will be on ML data science, but in the end, we will be learning about AWS cloud, and that too from a deployment standpoint. So we're not
I mean the
focusing
storage
on
point of your.
any specific cloud, but one cloud we will talk is on the AWS.
Oh, I mean the storage point of view or something like that.
Yeah, we could use S3 for that.
Okay. Okay. So if you do cross-functional, like in the training, we can train the the cloud. You will help us to learn that also, right? Do you have any
Yes,
questions or any issues?
yes, that we can cover.
Okay.
We are
Thank
very
you.
flexible. If you are say like, okay, we are from Azure or GCP, we can then blend our course accordingly also. That's not because I have experience in GCP, AWS, and Azure, all of them. So yeah. So we
Yeah, I
can.
mean, I don't want to deviate your course. Maybe we have some scenarios to want to implement in Azure. You guys
Yes.
guide us,
Yeah.
correct?
Yeah.
Thank you.
End of the session, Sitaram, any notes and any reference links will be provided for understanding purpose or getting some knowledge.
You mean any material, right? So
Yes.
generally, my course will be self-sustained with a lot of materials. So all those materials will be added to your drive. Any additional materials, if you require, like any reading materials or any videos external, as and when required, I'll be providing them.
Okay. Thank you.
All right, guys, thank you very much. And we'll come back tomorrow, same time, and then we'll continue our course. Till then, have a nice day. Enjoy your time.
Thank you.
Thank you.
Thanks, Sitaram. Have a great day.
Thank you.